Awesome. Thank you for that intro, Jason. Hi, everyone. Nice to meet you. Last session of the day. I guess I'm sitting between you and beer for Friday. So I'll try to see if we can finish this talk in 45 minutes or less. The goal of this talk is to make sure that we understand how various AppSec testing methodologies can work together. And observability is emerging as one of the popular up-and-coming ways to get visibility into applications, especially cloud-native applications. So today we're going to talk about what observability is, why is it kind of important, especially given the cloud-native landscape. And we're also going to touch upon why observability can stand on its own and be useful, but for the purpose of this OWASP talk, we'll talk about how observability, when used in conjunction with a DAST tool, and we're going to use OWASP ZAP as the example here, it's one of those things where 1 + 1 can be greater than 2. So let's dig right in. So these are the things that I had in mind. So I also wanted to make sure that while we talk about specific AppSec technologies like observability or DAST, we also kind of talk about the underlying reasons why these tools are important. Like, for example, it makes sense to talk about these AppSec challenges that are out there that are causing modernization of AppSec. Modern apps are being created these days, which is causing the need for a modern AppSec technology. And we'll talk about a little bit of that as well. And then we'll talk about the existing landscape of AppSec tools out there, starting all the way from SAST to artifact scanners to DAST and so on and so forth. And then figure out, what are the new things that are emerging given cloud-native applications, and how can these new technologies like observability complement existing tools like a DAST or like a software composition analysis, as well as provide additional visibility into runtime behavior, et cetera. And we'll end with, if you are thinking about planning your AppSec strategy, especially as your team may be going through digital transformation, you're creating cloud-native applications, how do you go about planning for that AppSec strategy, and what are some general North Stars that people tend to look for? And if you'd like to embark upon that journey, then it's good to think about certain things as opposed to kind of go deal with it when it happens kind of thing, right? And then we'll end with Q&A. So a quick introduction about what is DeepFactor. We're a Silicon Valley company. We're now a global distributed company. We are a cloud-native application security platform. Our goal is to enable engineering teams to quickly discover, resolve security issues, supply chain risks, and compliance issues during the course of development, so that when the application ships into production, it's already, there's much less number of risks in that application from a security perspective, from a compliance perspective, et cetera. How are we different from other AppSec tools, and why is there a need for a new generation of AppSec tooling specifically targeted towards cloud-native applications? It's because cloud-native applications have changed the way we build applications. So as apps get modernized and broken down into microservices, and you're moving into these modern application architectures with modern CI pipeline tooling, do you really want to take the baggage of the older AppSec tools and move on? Instead, a better way to think about it is to use an AppSec platform that is purpose-built for modern applications. That's essentially what inspired me to quit Cisco, which was my previous job. I'd sold my previous company to Cisco, and I was the head of the product team at Cisco's cloud business unit, and I quit my job and started DeepFactor to create a cloud-native application security platform. So DeepFactor summarizes a unified AppSec platform. It provides a combination and integrated experience between artifact scanning. It has software composition analysis, container scans, SBOM, et cetera, as well as runtime visibility in a unified experience targeted towards cloud-native applications. And it uses the concept of runtime observability to actually observe what's happening when the application is running by seamlessly dropping into your Kubernetes cluster or your containerized application and using the runtime information to not only provide visibility into how your application security risks are while your app is running, but also augment other AST tools like a DAST or like a software composition analysis to provide that unified kind of experience that results in comprehensive coverage and yet lesser number of high-value insights. That's the customary one slide that I have on DeepFactor, and the rest of this presentation obviously is going to be vendor neutral, and the goal here is thought leadership, not to pitch a product. But there's some really interesting technologies that we've created that I think it'd make for a fantastic kind of discussion. What is OWASP ZAP? This group, you guys are all experts in this area, so you probably already all know about OWASP ZAP. It's one of the popular DAST tools out there, open source, built by the OWASP folks, and it allows both AppSec teams as well as engineers to automate security testing from a dynamic application security testing perspective. You can even tie that into your CI/CD pipeline, so on and so forth. So let's talk about the broader AppSec challenges that are driving a change in applications, how application security is actually done. We're sitting at the intersection of a couple of interesting trends. Number one is the number of security breaches and the size of security breaches has increased tremendously over the last couple of years. And that trend is only going one way. Number two, digital transformation. Every enterprise company is a software company now. And every enterprise majority of them are going through a digital transformation where they're embracing cloud native applications. Their old monolithic applications are being broken down into microservices, Kubernetes, serverless, so on and so forth. There's some interesting stats that are coming out when you think about what's happening in this cloud native world. Number one is because of the newness of cloud native applications, everybody is kind of, a lot of the people are experiencing security related issues with Kubernetes or with cloud native deployments. Security related issues cause breaches, security related issues cause delays in engineering. You've caught early on during the course of development, but they still have to go fix it. It takes time. The number of applications being developed has skyrocketed. So IDC report says that by 2023, which is 2 years from now, we'll be looking at 500 million cloud native applications total globally. That's a lot of applications. And the number of developers today, we're sitting at about 26 million developers worldwide. And that number is going to get to 45 million developers by 2030. That's a lot of people as well. So a lot of people writing code, a lot of applications being created, a lot of applications being created with a modern cloud native kind of point of view. But the number of cybersecurity jobs, as you guys all know, especially from this conference, is very little. There's only 3.5 million, there's still 3.5 million unfulfilled cybersecurity jobs that are out there as of 2021. So if you put all of these things together, apps are becoming more complex. They're shipping at a faster pace thanks to CI/CD. There's more engineers writing code. There's more cloud native applications being shipped. And there's not enough AppSec people to test all of those things. So what is the solution? The solution is to make sure that we automate as many security and compliance related risk findings early on during the course of development so that the dev teams are equipped to understand these risks during the course of development and deliver a secure application. Enter DevSecOps. Now, what is driving this AppSec modernization? Apps are being modernized. That is causing AppSec to be modernized as well. Because if you think about it, if your apps are being modernized, you can't rely on the old AppSec tools. You can, you still have the option of putting together a hodgepodge of 5 or 6 different AppSec tools. And I'll go over some of the tool options that we have today. But that's cumbersome. Instead, now is a good time to start thinking about how do you reimagine your AppSec initiatives itself, and especially AppSec initiatives that align with your digital transformation initiatives. So when we talk to, we've talked to over 100 enterprises over the last year or so, and the reasons why each of these organizations is going through and thinking about AppSec right now and CI/CD, et cetera, is it can be broken down into about 5 groups. And that's kind of what we've done. One is app modernization. App modernization due to containerization, Kubernetes, serverless, et cetera, is causing them to think about what is the right way to secure these applications. Number 2 cause is, I want to make sure that I proactively embed security into the CI pipeline. So into my software development lifecycle, I want to make sure that identifying risks and security is baked in before that. That's a common theme that we hear from enterprises. Alert fatigue resulting in slowing down the release velocity is also a common theme that we hear, which is I have a bunch of tools one for code scanning, one for artifact scanning, one for container image scanning, so on and so forth. These all give me a lot of alerts, but it's too many alerts, and my team gets either frustrated with it and ends up not fixing it, or they end up fixing these alerts, a lot of them, which results in the releases getting delayed. The other thing is tool fatigue. There's a lot of tools out there. I don't want to put together 5 or 6 or 7 different tools as part of my CI pipeline to get visibility into all aspects of my application security behavior. Wouldn't it be great if I had a unified kind of experience across these tools? And lastly, especially as apps are being modernized and put into the cloud native world, there's a need to understand how these applications are behaving while they're running. And that's what observability can help us get to. That today is not possible with the existing set of tools, because they're either looking at code scanners, or they're looking at artifact scanners, or they're looking at DAST, or maybe IAST, but IAST was designed 10 years ago when Kubernetes didn't even exist. So it wasn't designed for these modern cloud native kind of applications. So observability is necessary because not only because you want to find issues in an application while the application is running, but it's also important because you want to correlate the observability findings with what your other scanners have produced, so that you can reduce the volume of insights and find richer, lesser number of insights for your engineering team to be able to triage them and result in greater velocity. So what is observability? As we discussed, observability is the method of evaluating applications while the applications are running to reach meaningful conclusions about the health of the application, performance of the application, and security behaviors of the application. So far, over the last decade or so, we've seen the evolution of APM tools. APM tools were the first generation of monitoring tools that were monitoring applications' performance and health. With cloud native, with the advent of cloud native applications, APM tools kind of morphed into observability tools, because they're now starting using the more accepted cloud native interception technologies to gather visibility into cloud native applications. And they're all calling themselves, the new breed of APM tools is observability tools. But they're still all looking at performance, logs, metrics, tracing, that sort of visibility. There's a couple of, a handful of companies that are now beginning to use observability from an AppSec perspective, because the telemetry that you gather from a running application is the same, whether you use it for performance, or whether you use it for health, or whether you use it for security. So far, as an industry over the last decade, we've used it for performance and health. Now we're starting to use it for AppSec visibility. So why is observability important for AppSec? Because number one, it helps you identify risky runtime behaviors that are not caught by static scanners. Let's say, for example, you have a developer. The developer brings in a piece of code, third-party code. That piece of code passes your SCA scans. There's no CVEs, no critical CVEs that are detected. Great. But at runtime, what happens is it reaches out to a certain geography. Let's say, for example, Antarctica. It makes an outbound connection to Antarctica. Your developer did not know that, because that's not part of the code that he wrote. Your developer did not know that the third party that he brought in did it, because it passed the software composition analysis test and there was no CVE detected. This is not a CVE, it's bad runtime behavior. There's plenty of such runtime behaviors. I just gave you an example of one, networking behavior, but it could be things like, your application used a certain port that it's not supposed to be used, or your application touched a certain file that it wasn't supposed to touch, or your application loaded a library from /temp, which is not accepted behavior. So there's lots of risky runtime behaviors that static code scanners will not catch, especially that runtime behavior exists in your OSS dependency or third-party dependency that is part of your application. And let's face it, today 75% of most applications is third-party code. So it's not only important for us to scan all of these applications, scan your custom code, not only important for us to get a list of vulnerabilities by using software composition analysis or container scanning, but it's also important for us to observe the application at runtime in order for us to get a full picture of the application security posture. The other benefit of observing an application at runtime is you also get to prioritize the vulnerabilities that are detected by your software composition analysis, for example, based on which of these vulnerabilities are actually executed or loaded at runtime. For example, if your black duck scan tells you there are 200 vulnerabilities in your application, combining that with an observability tool will tell you that out of the 200, your application only loaded 25 of them. It will help you reduce the alert volume of your software composition analysis tool, and therefore reduce the alert fatigue that your dev team might be dealing with. So those are the two fundamental benefits of using observability for AppSec. You identify risky runtime behaviors. You also use it to make your other security tools better, such as software composition analysis, by reducing the alert volume. You can also use it to make DAST better, which is what I'm going to talk about the rest of this discussion. And why is observability an absolute must-have when it comes to cloud-native applications? Because cloud-native applications increase the dimensions of complexity in more than one way. Number one, it's written in multiple languages, because you have one container that has a C application, another container that has a Golang application, another container that has a Java application, and they're all written by different teams maybe. Some of these developers don't even have standardized container base images, so they take one, that is an Ubuntu base image, another container image could have Alpine in it, and there's kind of no standardization because all they did was go to the Docker registry and get a certain base image and started working on it. It happens all the time. So it increases the surface area of risk because your applications are broken up into microservices. There's a lot more touch points to those applications that need to be observed as well. And purely scanning your static code is not going to cut it. Number three is you're now shipping faster all the way through to prod with CI/CD. You're also releasing more frequently. And that makes static scans insufficient because you need to complement it with observability. Now, there's a few different ways to observe a running application. Different technologies for the engineers in you. There are approaches like agent-based approaches, something like the sysdig-falco type approach, which allows you to have an agent on each of the hosts in, for example, your Kubernetes cluster. And each of the agents will basically use eBPF to track application traffic for file system behaviors or kernel system call behavior, et cetera, by looking at how the application behavior is converting to system calls and tracking those system calls using eBPF in the kernel. The second approach to doing that is sidecars. We've seen tools like Aqua or Palo Alto Networks, the Prisma Cloud product Twistlock in the past. Those are all tools that actually give you a sidecar, and the sidecar loads it's a privileged sidecar, so it loads a kernel driver that then ends up using eBPF on your host to then watch application system call behavior. There's a third approach, which is loading or preloading a library into your application's process. That's more of a user space approach. And it allows you to watch your applications in the user space without kernel mode drivers, et cetera. And that's the approach that companies like DeepFactor take. So we have different technologies that are used to observe applications at runtime. Which one is better for you depends on your use case and the problem that you're trying to solve. In some cases, it also depends on the persona that you're trying to solve the problem for. If your goal is to identify behaviors in production, you might have a certain, and the end user's operations. There's a different tool that might better fit your use case. But if our goal is to bake it into your DevOps pipeline and let the developers consume the insight, then you might need to use a different way of observing your application. So it really depends on which one, what problem you're trying to solve. Let's take a look at the plethora of AppSec tools that are out there. Interestingly enough, these tools have evolved over the last couple of decades. The funny thing is, all of those tools are actually important because they do slightly different things. And we've mapped them all the way from static to dynamic to runtime. On the static side, we have SAST, which is the most popular, AST tool. It's a code scanner. And recently, we've started seeing infrastructure as code scanners. It's still code, but it's the infrastructure as code like Terraform scripts and whatnot. That's also a code scanner, just a different kind of code scanner. So these things are static. They scan your code. Then you have artifact scanners, still static, but they scan your build artifacts. Like, for example, software composition analysis will scan your jar files or NPM files and identify which CVs exist in those files in the list of dependencies that you may have. OWASP depth check is a great project from the OWASP group that actually does a software composition analysis as well. Container image scanning is absolutely essential. Again, it takes the artifact. In this case, the artifact is a container image. And then it tries to find out risks that exist in the container image based on a list of publicly available vulnerability database. For example, the NIST database, which is publicly available to anyone, or something like a more custom homegrown database like a Black Duck or a Sneak, etc. Then you have dynamic scans. So static scans tell you, whether your code has some vulnerabilities or whether your artifacts has some known CVEs. They're useful, but they also spit out a lot of alerts. The volume is usually pretty high, and you need to make sure that you reduce that volume and prioritize it. That's important. The second thing is they miss out on a bunch of things that only dynamic scanners can catch. And that's where a DAST comes in. Like OWASP ZAP is a great example. DAST allows you to scan the application from the outside. It's not looking at your running application. It is sending your application a payload, and then your application returns a certain result. And based on the request and response, it tells you if your application is susceptible to any of the OWASP top 10 type issues, cross-site scripting, SQL injection, things like that. And then on the right side, you have runtime AST tools, application security testing tools. A popular one here is interactive AST tools, tools like contrast security, et cetera. They were designed, 10 years ago. All these tools allow you to instrument a language-specific agent. Like if it's a Java application, you say, okay, install a Java agent. If it's a .NET application, you install a Java, .NET agent. And they allow you to get visibility into how your application is behaving, by looking inside the application. And then you have container security tools. Container security tools allow you to either, these would be the Twistlocks and the Aquas of the world, or DeepFactor. These tools allow you to get, either a sidecar or a process visibility mechanism to get visibility into the runtime of how your containerized application is behaving. When you use, if you're building an application, depending on the type of application you're building, you need one or more of these types of tools in order for you to get comprehensive visibility and coverage into your applications. The problem is too many tools. You've got to tie them all together. You've got to manage them, set them up, etc. And you also have to deal with the alert volume in many cases. Therefore, in some cases, some people add yet another tool to take all of these alerts and then dedupe them, fine-tune them, reduce the alert volume, etc. So that becomes another tool as well. In order to solve this problem in the modern world, in the cloud-native world, we can actually leverage observability. If you observe the application while it is running using any of the mechanisms like a sidecar or an agent, like I said, or like a process-based inspection, then you get to see all the behaviors that application is exhibiting while it is running. You could track file behavior, network behavior, process behavior, memory behavior, so on and so forth, and take all of that telemetry, analyze that telemetry for anomalies, put that in a time series database, do anomaly detection, could be pattern-based, could be ML-based, and then you come up with runtime insights that actually can help you identify runtime security risks that lie in your application. So using observability can essentially serve, supersede, what IaaS in the past kind of offered for your cloud-native applications. It's much easier to drop in because it's language agnostic, unlike the first generation of, IaaS type tools. It allows you to watch your cloud-native application while it's running without actually changing any code or any of the container images. just by dropping it into your scheduler, or if you have Kubernetes, you can drop it into your kube cluster, and then you can start watching your application runtime. Delivers runtime visibility, great. But that's not just the use case. That is only one of the possibilities of what observability can do for you. If you use observability in the context of your DAST, it can actually help you enrich your DAST scanner by making it simpler, faster, and more comprehensive. I'm going to talk about that in a slide, a double click on that in the next couple of slides. The third thing that observability can do for you if you do it right is to help you prioritize the alerts that your software composition analysis or container image scanning tool is producing, and therefore reduce the volume of insights that you're seeing, helping your developers make the most of, make your software composition, find value in your software composition analysis tool. So the recommendation here is, no matter which set of tools you use, and no matter whether you use it from multiple different vendors or one different vendor, think about using observability to deliver runtime value, to improve your DAST scan behaviors and simplicity and comprehensiveness, and also improve your software composition analysis and other tools to prioritize and reduce the alert volume. Now let's double click into the middle part of here, of this slide, which is, let's focus on how observability can enrich DAST. How DAST and observability is one of those marriages where 1 + 1 is greater than 2. Let's take an example of a cloud native application. In this case, I'm talking about a Kubernetes application. So you have an app, 4 services, and those 4 services are running in a Kubernetes cluster, right? Now you need to run a ZAP scanner. So you set up a ZAP server, and then you start configuring it so that it points to your cloud native application. You ask your developer what your endpoint is for the app, and then you start scanning the endpoint. But oh wait, cloud native applications are, these containers are fleeting. They could come up and down, and they're ephemeral. That means the IP address of these containers might change. So you decide to put a load balancer in front of it, but you can't do that because you don't have access or your permissions to some of the network stuff. So you bring in your network admin or your IT admin to set it up for you, and therefore you create all of that. It's a cumbersome process today. So just to get started with a DAST scan, or OWASP ZAP, or any DAST scan, you need to have all of the networking equipment, et cetera, or infrastructure configured either by you or, in most cases, the network admin or IT admin to help you. So there's a pretty good amount of setup overhead involved, and it therefore becomes a project. Let's say you've gone and you've set it up. Step 1 accomplished. Then you go kick off your ZAP scan, and your ZAP scan is running. Your application is being scanned, and ZAP, when I say ZAP, I'm referring to both the web scan as well as the API scan for ZAP. So your application is being scanned. For web scan, ZAP uses a crawler. For API scan, it asks you to pass in a Swagger document. So you give a Swagger document, and it scans the APIs. But guess what? Your developers are not generally keeping your Swagger document up to date. Maybe there are a set of APIs that your application is, or URIs that your application is listening on, that are not documented as part of your Swagger. Or maybe those APIs shouldn't even exist in the first place. They should have been neutered or unexposed, but they probably are still lying there exposed. So what do you do about them? So it's essentially, the point is, the challenge here is there is a coverage gap with respect to the actual number of APIs and web services that are exposed by your application and what is actually being scanned, because especially for API scanning, it purely relies on a well-documented Swagger document or equivalent. The third challenge here for running ZAP with a cloud-native application, or any DAST scanner with a cloud-native application, is typically the scans are not intelligent enough to understand what changed inside your application. Therefore, every time the scan is run, you say, scan this application. It scans the entire thing again and again. It takes a lot of time. And scans many times are slow. So what is the fundamental problem here? The problem is there's no feedback loop that is telling the ZAP server to only scan the changed web services in your application, because there's nothing inside the application that is telling the ZAP scanner that these are the deltas that happened between release 1 and release 2. So these are the fundamental challenges with running a DAST scanner: setting it up, coverage gaps, lack of APIs that are documented, or always relying only on the documented APIs, and slow scans. These are the challenges when it comes to running a DAST scan with a cloud-native application. Now let's see how observability can help ZAP or any DAST get better. Let's take an observability, let's say the same application, but in this case, the application is being observed. So you pick whatever observability tool you want to use, whether it's a sysdig, or whether it's a DeepFactor, or whether it's a Aqua, and you drop it into your kube cluster. What happens then is your containers are being watched or observed because there's an agent that is, or agent or library or whatever approach you take, that is listening to these containers and observing the changes in these containers, the IP changes, which web services are they listening on, what ports are they listening on, all of that is being observed by this watcher. Let's call it a sensor that is observing your containers. This sensor, if you pick the right tool, can actually have a feedback loop back into your ZAP server or your DAST platform. This is an area where we actually ended up filing a patent last year, and it's super cool. In fact, what we did was to solve this problem number 1, which is enabling the ZAP server to see your application container and scan it, even though the IPs of this application keep changing all the time. We baked in a little proxy into this orange dot. That proxy allowed us to tell the ZAP server what our IP is that it needs to start scanning. So as soon as this container comes up, that proxy is there, and the proxy tells ZAP server that you can scan me, I'm here, this is my IP. So now you don't need to go set up a load balancer, etc. All you have to do is drop this little thing into your kube cluster, and then you go to your ZAP, configure the integration, and say scan. That eliminates the need to involve a network administrator. So now you don't need that network administrator to come in, set up load balancers, all of that routing. And that routing doesn't need to be updated all the time, because anytime this new container comes up, your ZAP server knows exactly where it lies, what its IP is, and how to scan it. You can even use it actually to scan internal services, not just the ones that are exposed outside of your network, or the externally exposed endpoints that are typically scanned. You can even scan the internal endpoints and get some interesting insights there too. Number 2 is observability can enable you to get a lot more comprehensive coverage with respect to scans, because it is watching your application for new web services created, new APIs that it's listening on, etc. And therefore, even if you have certain undocumented URIs or APIs in your application, the observability sensor in your application now knows that these are the new APIs, and then it can go tell the ZAP scanner to go scan those things. So it doesn't have to. So you don't have to have a properly documented Swagger interface. You can actually your ZAP scan now can give you a more comprehensive list of coverage of your URIs, because the sensor that is observing your application from the inside actually has a feedback mechanism into the ZAP scan server. The third one is reducing of scan times, because now your application, the observability sensor in your application, is actually watching the changes that have happened in your application between release 1 and release 2. So for example, if your application opened a new web service or started listening on a new web service between release 1 and release 2, then you only need to scan that. Maybe you don't need to scan all of the endpoints all the time. And that will help you only scan the deltas. And if the sensor tells ZAP scanner to scan only the deltas, then the scan time will be drastically reduced as well. So these are 3 examples of how observability, if working together with a DAS scanner, can actually improve the DAS scanner at the same time providing value, like 1 + 1 greater than 2, precisely. So let's circle back to, hey, I'm building a cloud-native application, or my team's building a cloud-native application. How do I go about thinking, planning for my AppSec strategy? I'm sure many of you guys are experts here. For those of you that are looking for some guidance in this area, then the guidance here is, first think about your business driver. Is your business driver digital transformation or app modernization? Or do you simply want to take your legacy application but put security into your CI/CD pipeline? Or are you more governance driven or compliance driven? Is it the new Biden SBOM executive direction that is making you take this stance, or do you need to comply with something? Once you understand your business driver, you also need to understand the persona that is going to be using the tool. Like, is it your QA team, your ops team, or do you want to have visibility into the devs? Or maybe it's a combination of the above, where your DevOps team, with guidance from AppSec, sets up your CI pipeline and bakes security tools into it, and your dev teams is the one that is consuming the insight. Whichever it is, I think you need to properly understand that and have some kind of a process so that you can make sure that that's a viable process. Triaging timelines, who's going to triage it? At the end of the day, there's going to be some work involved. It's never going to be zero, so you have to make sure that that's planned for. The third one, which is an important part in this puzzle, is what are your technology requirements? Are you dealing with a mobile or desktop application, in which case you need to pick a different set of tools? Are you dealing with a predominantly VM-based deployment with a legacy like .NET or type workloads, in which case you need to pick a different type of tools? Or are you dealing with some of the more modern cloud-native applications, in which case you need to pick a different set of tools? So understand that, because one tool does not fit all, and many times it's not in this AppSec world, it's not one tool, it's usually a combination of many tools. So pick the set of tools that makes sense for your application set. And lastly, your budget, timeline, et cetera, et cetera. With that, I wanted to conclude this presentation. I promised 35 to 40 minutes, so here I am, 37 minutes in. That's my slideshow. If you'd like to contact me, my email is here. You can always go to DeepFactor.io, or you can email me at Kiran@, or you can hit me up on LinkedIn. Happy to take any questions.